Well, hello and welcome. And what I'd like to do today is to discuss how a well monitoring system in Tanzania could use machine learning and benefit from a child's game called a jigsaw. Now, we all know that we all learn through play. With toys or with almost anything really. And the child's game, the jigsaw, where you assemble things to make a bigger picture, I think is a useful analogy when we start to develop machine learning tools for the well system out in Africa that we are trying to install. But first let's go into what machine learning is and give you an example that we did the other day. Well, here we have the diagram of the machine learning mechanism. We have an input, we have an output, and we have what's called hidden layers. We can come and talk about that later. And we have the neurons and the bias parameters. But in this particular case, I started with a sine, 30 degrees, 45 degrees, angles, trained the network, and what happened? It gave me an output, which was fantastic. My very first machine learning mechanism. Could use rather than degrees on a sine wave, we could use a pump count, the amount of water being pumped by that particular well over a period of time. And for example, it could be giving 1,000 litres a day, then 900 litres a day, and 800 litres a day. And guess what? This would be trained to say, well, at 500 litres a day, there is something wrong. We need to fix it proactively rather than wait for it completely fail. Let's predict it's going to fail, which is obviously straightforward, but it doesn't really need machine learning for that. We just have a level detect when it falls below, let's say 500 litres per day, then we can just say trigger an alarm. But nothing in life is that easy, is it really? Right, let's take a look at this particular picture neural network with two inputs. We have got the pump count, the volume of water per day, for example, and this time let's make it the rainfall. We would trigger this to need some help, let's say 500 litres per day. But with additional rainfall, the people out in Tanzania harvest the rainfall and use the pumps less. So, of course, the pump output will be less. So far from being the pump failing at 500 litres per day, it just means that there's more rain that day and therefore they don't need to use it. And so we need to train this network with two variables. But things aren't quite that simple, are they, either? Because there's not just two variables, there are a number of variables. We talked about the pump count that particular day. Which day are we talking about? The cycle count, how many times the computer goes around its little loop. We've got the battery voltage, maybe it's nothing to do with the rainfall of the pump, it's maybe the unit itself, looking at the battery voltage, the rainfall, and we look at pump counts in various co-located or closely related wells. Obviously, with all those inputs, we can't possibly cope with this type of diagram. We have to look at a bigger diagram. Right, this was the diagram that we're thinking of. We're having 6 inputs. We have 6 input splitters and parameter conditioners going into these neurons. These then go into the hidden layers and collected at the outputs to give us a red, green or blue, red, green or amber signal of the well after it's learnt which is good and which is bad. Now, that's very generic. We don't need some of this. It's just overly complicated, and we could get into a whole lot of trouble with false minima if we did use this many neurons. So we decided to, that's the affine function, rather, y equals mx plus c, where c is non-zero. So it's quite straightforward. Weights times x is x1, x2, x3 times the weights summed minus the bias, and the activation function. So we don't need that full diagram, we just need this. Right, here we have those 6 inputs, say, conditioning, signal conditioning, and these are the neurons. Now, if you look, we have here the inputs of those parameters. We have the weights, which are purely random. It can be anything we want. Then we have that times that, all added together from all of them. Then we apply the sigmoid and subtract the bias to give us an output. There are other things, dropout ratios, but never mind about that. But this is basically the input and output for a neuron, and this is where we think the child's jigsaw picture is emerging, because this, rather than being a very large spreadsheet that we seem to see everywhere, associated with all these machine learning tools, and say, well, why doesn't a diagram actually help us? And we can just copy and paste those neurons, inputs and outputs, wherever we like, to fit what we think will be a correct neural network machine learning mechanism for our specific task. So that's where the jigsaw comes in. So we have to just think about that neuron, just in one individual one, and copy and paste. Well, that's the idea. We will see how it goes, and we will add to this video its success or otherwise. Cheers for now. Oh yes, what's all this? Just to remind us. Yeah, okay.